everyone, and welcome to the Circuit Breaker PSE Ethereum Foundation Workshop, Anon Aadhaar. Joining us today is Yannis, who will be taking us through this session. And with that, I'll pass it over to Yannis to get the session started.
Hey, thanks. Hi, everybody. Super thrilled to onboard you on Anon Aadhaar today, and can't wait to see what are you building during this hackathon with our protocol. So let's dive into it. So here is a summary about the presentation that I will do today. So with an intro, a problem statement, and then I will go through all the details about how exactly the protocol works and how you can use it inside your apps. So let's get started. So what is to introduce what is Anon Aadhaar? So Anon Aadhaar is a ZK protocol that let Aadhaar citizens prove their identity without revealing any information about themselves. So Aadhaar is a proof of residency for Indian citizens. So our protocol is only focused on now, on the Aadhaar identity, and I will show you what you can do with the protocol. But first, let's just give a quick problem statement, what are we solving with our protocol. So our protocol is achieving anonymous proof of identity. So in the current system, so you have governments. They are basically the owner of your identity. They have a big registry with all your identities, and they give you your identity in the form for yourself in the form of an ID card. So the governments here assign and issue your identity, and they can give you, for example, a number, and this number is attached to all your information about your identity. And so the goal here, that what we're trying to achieve, is that how we can build a prover such that the prover can construct a proof from your identity that attests that you're a human and that you have an identity, and convince a verifier without revealing any information about this identity. Achieving that is a big step because, of course, it's hiding a lot of personal information, and it's very useful in the case of blockchain when you want to breach your data on chain, or that you just want to prove that you're a human on chain. So what is Anon Aadhaar? So Anon Aadhaar is basically doing what others can do with digital identities that are signed. So in the case of Aadhaar, so the protocol is based on some documents that are signed with RSA, which is a signature algorithm, and SHA-256. So in the protocol, we are basically verifying both the hash of the signed data and the signature, but we are doing it inside of a snark, and we are using Circom Gross 16 to achieve that. And also the protocol right now is achieving uniqueness of the proof. So we can attest that we can for one identity, the proof we can output some identifiers that will remain the same without causing any trouble for the end user privacy. Anon Aadhaar is served through a TypeScript SDK, a Solidity library, and a React library. But I will get deeper into that after. So how does it work? So as I said, right now the protocol is using what the UADAI, which is basically the government agency that is issuing identities and signing identities. So they are using this thing that they call secure QR code, and so this QR code contains all the fields that are listed here. So you have a reference ID, which is the last 4 digits of your Aadhaar number, and the timestamp. The timestamp is representing when the data was signed, and also you have the name, the gender, the date of birth, the hash of the mobile number, the hash of the email, the address, the photograph in bytes and a signature. So we are just scanning this QR code that you can easily find on the Aadhaar mobile app or on the printed Aadhaar letter. So we scan this QR code. We have like all this raw data that we can then like separate between the signed data and the signature, and then we can process that into our circuit. So what exactly our circuit is doing? So here is a scheme that explains all the steps that we are achieving inside of our circuit, resulting into a snark proof. So first, let's go through the inputs. So as I said, we have like the signature, we have the signed data, we need the RSA public key. So in the case of Aadhaar identity, it's something that is publicly published by the UIDAI. You will find in the documentation, the website, the registry, where you can find like all the production and test public keys. You have like also the signal hash, which is I will explain this feature in the slide after. Oh, sorry, there is a typo here. So there is 2 times. So there is the RSA public key, and here instead of public key, it should be the data length, the length of the size of the data. So first we apply SHA-256 on the signed data, because in the case of the RSA algorithm, it's not exactly the data that is signed, it's the hash of the data. So in the process, you have like basically the raw data, and then you hash it, and then you sign the hash with RSA. So inside of the circuit, we need to recompute SHA-256 inside of the circuit to ensure that the data we will compute inside is actually authentic and is the data that was signed. Then we verify the signature with the public key and the sign and the hash and the SHA-256 hash of the signed data. And then once we are sure that both the hash is verified and then that the signature is verified, now we can start to compute data, and then we are extracting so the last 4 digits of the Aadhaar number, the time step, the name, the date of birth, the gender, the PIN code, and the photo. So we need this data to compute 2 kinds of nullifiers. There is the user nullifier, which is the hash of the last 4 digits and the photo, the identity nullifier, which is the hash of the last 4, the name, the gender, the date of birth, and the PIN code. Then we convert the timestamp. So remember, the timestamp is the timestamp of when the QR data was signed. So it's basically like every time you will request on the Aadhaar app, or every time you will want to generate like a Aadhaar PDF. So the timestamp is the timestamp of when this document is signed, and then we sign the signal hash. Again, I will explain this mechanism in the slide right after that. And so in the output, you have like these outputs: the user nullifier, the identity nullifier, the timestamp, the public key hash, and the signal hash. So now that we know that, okay, so what can we do? What can we leverage with all of that? So the user nullifier, it needs to be used as to prevent double spending, proof double spending. So it's used to prevent user for forging 2 different proofs with the same identity. So this is the hash of the last 4 digits that will remain the same no matter what you change in your identity. Your Aadhaar number is supposed to be to remain the same during all your life. And then you have like the photo bytes, and so this photo it's something that will last for at least 15 years. So maximum 15 years. So this user nullifier should remain the same for quite a long period of time. But it can happen that, for example, you change photo, and in this case, your user nullifier would change. So that's why we also compute an identity nullifier, which is here more like that you can use as a recovery method. So let's say that I change my photo, so my user nullifier change. You can easily ask to the user to input so all the fields that we need to compute the identity nullifier. So the name, the date of birth, the gender, and the PIN code, and the last 4 digits of his Aadhaar number. And then you can easily like verify, oh, okay, so he's able to recompute like the identity nullifier, and then you can like link this identity nullifier to the previous identity nullifier and user nullifier you recorded into your database like long time ago, for example. Then you have the timestamp. So we are processing the timestamp to output it like as a Unix UTC timestamp. So which is very helpful, like for example, for on-chain verification. You can check it over the block timestamp, for example. And so we are outputting the timestamp as a security. So it can be used as a one-time password system. Because as I said, so this timestamp is the timestamp of when the data was signed and generated. So meaning that you can really use it as a one-time password. Let's say that you want to have more security against thieves, because like as it's a QR code, anybody can find a PDF or even I don't know, like have like an application open with the QR code displayed, and then scan the QR code and generate a proof. So to prevent that, we are checking the timestamp, such as you can into your apps choose the level of security that you want. So it can be an hour. It can be like, okay, I want you to show me a proof with a data that was generated, like I don't know, like in the last 3 days. So it's something that you can choose, and it can be done. This check can be done either like on chain or off chain. We are also outputting the public key hash. So that's more something that we use to optimize gas fees, because like in the case of RSA, the public key can be like quite huge. So just having to check against the public hash is easier, and it's also something that we store into our smart contract to be sure that the public key that was used is the UIDAI public key. Because in the case of our secret, so if the data is different from QR code, of course it will not work. But if you go to the basics and just think about SHA-256 and RSA, you can present to the secret whatever, like SHA-256 and RSA signature, and it will generate a proof. You really need like to ensure that the public key that was used while verifying the RSA signature is the one from the UIDAI. And also, so you have the signal hash. So the signal is a mechanism. It's really like it can be seen as just sending a message. So we mainly implemented this feature for first prevent front running on chain. So let's say that you have like a smart contract, and you ask the user to vote, like to send a valid Anon Aadhaar proof. It's quite easy, like to just take the proof from the mempool and replay the vote before the others did with the same proof. So by using the signal hash as a front running mechanism, you can like use it as a front running to prevent front running. Sorry. So what you can do is that, for example, you can ask the user, like when he's generating his Anon Aadhaar proof, to set his address, Ethereum address, as a signal. So when he will generate the proof, it's gonna like basically apply a constraint on this signal. So when he will send his proof on chain, you can do in your smart contract a logic such as the signal is equal to the sender address. And also it can be used, for example, if you plan to, I don't know, like build a NERC 3337 wallet for this hackathon, it's now completely possible, and you can use the signal hash as a signature mechanism. So, for example, you can like just basically like have like the representation of the transaction, hash it, and input the hash of this transaction as a signal, and then generate a proof. And so you can use the identity to sign your transaction on chain with your account abstraction wallet, which is kind of cool if you think about it. Okay, so now let's get more practical. We implemented the SDK, so it's such that it's going to be like really easy for you like to integrate it into your apps. So we are switching from the a bit more complex part to the more easy part. So you have like this React library it's really seamless to integrate. It takes under 5 minutes. So you just install the React library. Then you just need to initialize the provider at the root of your app, and then you can like use a simple hook that will give you the status. The way you can use the React library is mostly, for example, for authentication, but you can use it also like to just ask the user to sign data. And so yeah, and you have this component login with Anon Aadhaar, which will display these two components. And so here is the components where the user is asked to log in or at least to generate a proof. And so what you will need to input his Aadhaar QR code as a PNG. So it can be quite easily downloaded on the Aadhaar app. As I said, you can directly download the PNG, or you can also have it like on the PDF print letter. But in this case, you will need like to screenshot it. Like we did some tests. If it's like a quarter of the PDF, it works. If the screenshot is a bit wider, it can be a bit messy. But as I said, on the Aadhaar app, you can easily like just download directly the QR code as a PNG. So yeah, as I said, so if in the case you want the user to sign some data, you can just like pass the signal you want the user to sign, and it's gonna be displayed inside the component. So verifying a proof of chain. So then you will need to use like the verify method that you can import from the Anon Aadhaar core library. So you will need to install this one too. And just want to highlight here that at this moment is where like you can have like custom methods to check against the signal or the timestamp. So as I said, you can use the signal like to ask the user to have whatever commitment that you want him to have, then you can also check against the timestamp to set the rules in terms of security that you want to have. Do you need like something that is really secure, and like you will ask like really for a proof generated like less than 15 minutes ago, or you don't care, and then you don't have to check against the timestamp. Yes, so just wanted to highlight here that if you're using like the React library and you use the login with Anon Aadhaar component, the verification of the proof is done like at the login moment. So in how it works, how does it work is that you ask the user to generate the proof. then it's gonna start generating a proof. And once the proof is generated and the proof is verified, and if the proof is verified, then the user is logged in. Verifying a proof on chain. So as I said, we have a Solidity library that you can also install into your Hardhat project. Some really important stuff here. So as I said, so if you want to nullify an action into your smart contract, let's say a vote or an airdrop, you really need to use the user nullifier and to map it like with a Boolean, and not use the message sender address, because in this case, anybody will be able like to just with the same proof to send a proof that will pass the check with different addresses. You can use the signal as a way to prevent fault running. So that's a mechanism I explained before, and you can see here. So the check. So we are just converting the message to the sender's address, and we are checking that it's equal to the signal, and then the signal is passed to the Anon Aadhaar verifier. And then also in this, so this example smart contract is available like on our boilerplate that you can find here. And I will also post the slides on the Discord channel, so no worries. And so yeah, you can have like a basic method that will check like, oh, okay, so is the data that has been used to generate the proof was signed, more or less than 3 hours ago. And then you have like you can so easily import like the Aadhaar verifier. We have some Aadhaar verifier deployed on Sepolia and Scroll Sepolia. You can find the addresses in our mono repo, and then when you will deploy your contract, you will just need to construct your contract with the verifier address, and then you will be able to import the interface and use it that way to verify proofs. So what actually you can build with Anon Aadhaar? So there is quite some fun stuff to build. Quadratic funding voting applications based on T-bill resistance mechanism. You can build a Gitcon passport based on Anon Aadhaar, a check-in app, something more DeFi with so for example, a microloan application. You can build a replicate of Twitter or Farcaster, but just for Indian citizens. You can build a SSO server that is based on the same mechanism, but without having to just by sending the proof, and then the user can have like one place where he can manage his proofs. And of course, yeah, on-chain voting polling can be also quite fun to build. It can be also off-chain. Just want to highlight here so that a ZK proof is not meant to be live only on-chain. You can also build use cases, part of your use cases, or where you need like the proof to not be committed on-chain, and then have like other mechanisms that happens on-chain. You can choose. Just want to highlight, yeah. So don't be afraid. Like if you verify your proof like off-chain, it's also like really useful. In terms of price, we have like a $1,000 prize for this hackathon, rewarding the best integration project using Anon Aadhaar. So we don't have like any specific criteria here. We just want like to judge in terms of technical integration, the use case, the UX. Is it really solving a problem? And is it something that is something for a bit more for the real world? And yes, and the good news is that you will be we just launched this new version today. We are very happy. It's been a month of hard work So yeah, can't wait to see what hackers are going to build during this hackathon. And here is a link to our mono repo where you can check all the codes integration. You have links to our documentation website. You have a quick setup app that you can fork, and you can start working with it. And you also have like a boilerplate app, which is more like it's a very small voting app, just to showcase what you can do with Anon Aadhaar.
Awesome. Cheers. Thanks, Giannis. If anybody has any questions, please feel free to type them in the chat or take yourself off mute as well. You can ask directly. And if there are none, then of course you can always reach the PSE team at the partner Discord channel as well. Just make sure your hacker dashboard is connected to Discord. Yeah, they will be there to help answer any questions around this. So thanks again, Giannis, for the great workshop presentation. And thank you everybody else for attending. This was our last workshop of the day. We just have team formation session in about 30 minutes, which will be the final one. Yeah, hopefully I don't see anybody there because everybody's already found a team. So awesome. Well, cheers. Thank you all. Thanks, Giannis, again. Have a great rest of your day and have a great weekend and happy hacking.
Thank you all. Bye. Have a good one.